So guys, in this video lesson, we are going to give attention to the full-blown question which I promised we are going to deal with in the next physics tutorial class. And so I'm saying welcome to the GMAT 41's physics class as we look at these questions. Of course, these questions are linked to part 1 of elasticity and Hooke's law that we treated in our past classes. I want to believe that you've taken the video lesson on part 1 of this elasticity and Hooke's law so that you can follow up very well as we deal with these questions. These questions, you see them, okay, titled jump question. However, that shouldn't bother you. When you talk about jump question, does it mean that the questions that jump asks, they are different from what other exam bodies asked? No. WAEC also asks questions related to this. NECO also asks questions related to this. Now, it's interesting to know that this topic we are dealing with also stretches into higher level. 100 level students, they deal with this in their physics under mechanics. Is that okay? And that tells you that you want to take this lesson very seriously, no matter whether you are in SS1, SS2, or SS3, whether you're preparing for a WAEC, whether it is JAM you're preparing for, or whether you are in 100 level. If you are yet to subscribe to GMAT 41's YouTube channel, please kindly hit the subscription button. No holding back. Here we got you covered. Is that okay? You can always count on the GMAT 41 as we carry you through in your studies. Think physics, think chemistry, think mathematics, other engineering and science courses. Here at GMAT 41, we give them to you just as you need them. On the board here, we have our first question we're going to look at. A spring of force constant 400 Newton per meter is compressed such that its length shortens by 0.05 meter. Calculate the energy stored in the spring. So we have to calculate the energy stored in the spring. The force constant of the spring is given to us to be equal to 400 Newton per meter. Okay, you can write it this way still if we want. The unit, Newton, then slash meter. Now we are told that this spring, okay, the length was compressed, was shortened by 0.05 meter. Now I would like you to take note of this. When that statement is used, that something is increased by or something is shortened by, they have given you the difference in value. Are you getting me right? So if you have initial value and final value, one could do final minus initial to get a given value. When an examiner uses that word by, either something is increased by or shortened by as you have here on the board, it simply means they have given you the value of that difference. Please, you want to take note of this explanation that I've given. You can put it down somewhere in your notes. Are you following right? Once that word by is used, they have given you the difference already. They have given you the change. They have given you the final minus the initial value. Having said this, I can proceed to say that, okay, here, the final length of the spring minus the initial length of the spring has been provided for us. Does that make sense? I can say that L1 minus L0, which of course is equal to extension, is given as 0.05 meter. Now the examiner asks us to find the energy stored. The energy stored in the spring, we don't know. Now recall that we've established that energy stored in the spring is 1/2. Now they gave us force constant, okay? So since force constant is given to us, it's going to be Ke squared. So that is it. It's just about you remembering the formula and that's all. And of course, if you have been following GMAT 41's classes, this would no longer be a problem. We are going to substitute here and then the energy is going to be 1/2 times the force constant is 400. We're going to multiply by square of the compression because in this case, the spring was shortened, which from the data given is 0.05 and then you square. Now we are going to solve this out. Remember there is no calculator. So let us say that this is 2 divided by 2, you get 1. 2 can also divide 400, you get 200. Let us look at the square of 0.05. How do you handle this? Let's say without calculator. Okay, it's a simple thing. For you to have 0.05 squared means that you're multiplying 0.05 by itself. That is 0.05 times 0.05. So what's the fastest thing to do here? Just multiply the non-zero digits, okay? In this case, 5 times 5. and that is going to give us 25. So I'm going to write this to be equal to 200 times, like I said, you're going to have 25. How about we do something rough about it? That's going to be 25. Okay, then in that 25, take note that 0.05. Now you have how many zeros altogether before the non-zero digit 5? In the first 0.05, you have 2 zeros before the non-zero digit 5. In the second 0.05, you still have 2 zeros, okay? So in both cases, 0.05 times 0.05, you have 2 zeros, which is altogether 4 zeros before this 25 that you obtained here. So we're going to write the 4 zeros just before the 25. You know, this thing is 0 points. The whole number is not a non-zero digit. The whole number is not a non-zero digit. So for that reason, when you're writing that 0, 0, it's going to appear before the 25 that you obtain. Now with this, we have, let's say, an invisible decimal point just after the last digit. We're going to move that decimal point 4 times. Why? In 0.05, if you are multiplying it by itself, you notice that the decimal part, the first 0.05, you have 2 decimal digits. The second 0.05, you still have 2 decimal digits. Altogether, there are 4 decimal digits, and therefore, we can move this point 4 times. 1, 2, 3, and 4. So that this is going to be 00.0025. And 00 is simply 10. So we're going to have 0.0025. Good. So that's going to be the value of 0.05 square. Are you following, right? GMAT 41 can really help you when it comes to multiplying and or dividing decimal digits. Okay, if you know you have challenge with this, how to handle them without calculator, below this video lesson, just drop your comment requesting for assistance on these aspects of how to handle decimal numbers. And GMAT 41 will just be right there to assist you through our basic maths class. Does that make sense? Feel free. Remember, you need this, okay? So nothing should hold you back. I already told you I'll be there to just help you out. Now we have 200 times 0.0025. How do you quickly get the product of these two numbers without calculator? The non-zero digits, which are 2 in 200 and then 25 in 0.0025. Multiply these two by 25. If you multiply 2 by 25, you get 50. So we write the 50. Are you there? Now observe that in 200 you have 2 zeros. The 2 zeros appeared after the non-zero digit as a whole number, as a whole number. For that reason, that 2 zeros, add them or attach them in front of the 50 you obtained by multiplying 2 by 25. And then you notice that in these 5, you have 0.00, 3 zeros before the non-zero digits. Since that part is a decimal number and the whole number part is 0, are you following, right? That means you're going to fix 3 zeros just before the 50. Is that okay? So this is what you do. And once again, we have an invisible point just after the last digit on the right. So what would we do? We have to move that point a number of times. The question is, how many times would we move it? That depends on the number of decimal digits you have, okay? Here, the decimal digits we have, there are 4. 0, 0 to 5. So we're going to move this point 4 times. 1, 2, 3, and 4. So this becomes 0.5. Now 0, 0, 0, we don't have any point here, separating those zeros. So if you have 0, 0, 0, it's still the same as 0. Then before this point, which means that all this thing can just be written as 0.5, then 0, 0 there. In conclusion, the energy stored in the spring is 0.5. If you like, you can fix another 0 or the value. Choice is yours. If you want to leave it at 0.5, it's still correct because this last 0 is insignificant. So this is the energy stored in the spring. And of course, the correct option here is option D. Alright, take note of this multiplication. Subsequently, if we meet something like that, I'll be very fast in analyzing it. Like I said, if you want a special assistance regarding how to handle multiplication or division of decimal numbers, even when they include 0 as whole numbers, are you following, right? Please, GMAT 41 is always here, okay? Through the GMAT 41's basic level mathematics, I am going to put you through this and you won't have any problems regarding that anymore. Let us move on to our next question, number 2. A string of length 4 meter is extended by 0.02 meter when a load of 0.4 kilogram is suspended at its end. What would be the length of the spring when the applied force is 15 Newton? Acceleration due to gravity G is equal to 10 meter per square second. To handle this problem, we want to take a look at the fact that the string had an original length, the natural length of the spring, which is 4 meters. So permit me to write that out, 4 meter, alright? That's the original length. And then the spring is said to be extended by 0.02 meter, the use of the word by. Again, just like the previous question, number 2. This question number 3. By the way, remember that there was this special video lesson I released on question 1, okay, where we had a mass fell on a spring and then compressed that spring. Okay, now let us move on. This extension was produced when a load of 0.4 kilogram was attached. You can say that extension, let me use E1, the first extension, okay, was given as 0.02 meter, and that happened when a load. Now this load was given in the unit of mass, kilogram. I am going to convert it to Newton. If you remember, in part 1 of Hooke's law of elasticity and of course elasticity, we established the fact that force is equal to mg, just like you have weight equals mg, okay? So that converts mass in kilogram to weight or force in Newton. So we can say that F1, that force that produces extension, 0.4 multiplied by 10 mg, okay? And so we are going to get 4 Newton. So it's this 4 Newton force that extended the spring by this value from its original length, giving an additional 0.02 meter length to it. Okay, so having done this, we're now required to find what the new length would be, okay, when a force of 15 Newton is applied. So we're going to write L2, we don't know. I'm using L2 in this case because that is on a condition that a new force, F2 equal to 15 Newton, was applied. Take note of this. Original length of the spring is 4 meter. When it produced an extension of 0.02 meter, there was actually a new length obtained. And I'm going to tell you, if the original length is 4 meter and the extension is 0.02 meter when this weight was added, this load, it simply means that maybe you had the spring to be something like this, length 4 meter. Now there is an extension of 0.02 meter. So let us say now that the spring extended up to this level. You now see that to get the new length under that condition 1, the initial condition, is going to be 0.02 plus 4, which will give you 4.02 meter. So the new length in this case, in case 1, which we can term L1, that new length is actually 4.02 meter. That was when this load was attached to the spring. Now in this case, case 2, when the force is 15 Newton, we are now being asked what is going to be the new length, and that's why I use L2 here. Now from that, our part 1 class on Hooke's law of elasticity, I established that we can write an equation in this form F1 over E1 equal to F2 over E2. Now in this E2, we were not given extension 2. What we're asked to find is L2. But we know something that this guy, look at it, extension 2 can be established to be L2 minus L0. That is how we actually got this extension 2. Are you following? That's the second extension, which we are asked to find. So what we are going to do using this formula is get E2 simply. And once we get E2, we now make it equal to L2 minus L0. We know our L0, the original length. Are you following, right, of the spring? Now we're going to proceed in substituting. F1 here is equal to 4 Newton, and that's going to be divided by E1, and E1 is 0.02. That's going to be equal to F2, which is 15, divided by E2, we don't know. And of course, we can cross multiply here. Solving this E2 straight is going to be 0.02 times 15. We're going to divide this by 4, cross multiply, and then make it to subject to the formula. Now if I multiply this, 0.02 times 15, quickly, what do? 2 times 15, you get 30. You get what? 30. Now notice that this 0.02 is a decimal number. Are you following, right? So how many zeros do you have before that 2? There are 2 zeros. So in that 30 you are going to place 2 zeros before the 30. What am I saying in essence? We expect to get something like 0030. 0030, okay? So there is an invisible decimal point just behind the last 0 in 30. What do? Move that point how many times? The number of decimal digits you have here. That's 2 times. So you're going to move If you move that point from behind the 0 after that 3, move it 2 times, that's going to give us 0.3. So this is actually 0.3 and then divided by 4. So that E2 is actually equal to, can we divide this? How do we divide decimal digits? Very simple. Remember, I told you from here at GMAS 41, we continue to give you our best, okay? To make these things very simple to you. There's nothing there, all right? It's quite easy to understand. The secret is as simple as go and learn your multiplication table. I have always sung this. Is that okay? Learn your multiplication table, please. It does not matter the level of learning you are. At least if you learn your multiplication from 2 to 9 times table, you are good to go in understanding all these things. So let's do the division and see. 4 divides 0. That is 0 divided by 4. Of course, it's not possible. Yeah, 0 over 4 is going to give you 0. So I'm going to write 0 here. And then after that, you have your decimal point. Let me fix that. Now let us deal with the decimal part now. 3 over 4 is not possible. So what do you get? It's going to be 0 and then remainder 3 again because 4 cannot divide 3. So 0, remainder 3. Now what do you do with that remainder 3? Have it in your brain. Attach 0 to the back of that 3. You get 30. Divide that 30 by 4. Are you getting me right? So how many times can 4 go into 30? Just 4 times table will answer that question for you. 4 can divide 30 7 times and there would be a remainder of 2. Is that okay? Now, that remainder 2, attach 0 to it again, divide it by this denominator 4. If you have 2 and you attach 0 to it from behind, you're going to get 20. 20 over 4 will give you 5. So this is the extension, you know. We can choose to approximate the extension to 0.08 meter. That's the extension that's going to be produced by first 2. But the examiner didn't ask us to find the extension produced by 15 Newton weight. The examiner asked us to find the length of the spring when this force is applied. Remember, the spring originally was 4 meters. If you apply a load, a weight on the spring, that spring will extend. So the extension in case 2 is 0.08. Now, under that condition of extension, what will be the new length? That's what the examiner is asking of us. So we can now recall that E2 will be equal to L2 minus L0. I already explained that earlier. So that if you substitute, it means that 0.08 is equal to the new length, which we don't know. Then the original length is 4. Collect your like term. This new length that the examiner is asking us to find is going to be, this 4 we move over here. You have 4 plus 0.08, and that gives us 4.08 meter. So this is the new length of the spring when this 15 Newton force is applied to that 4 meter original length of the spring. The correct option here is option D. I hope you love this, right? Learning made fun, easy, homely and targeted. Yes, that's what we try to offer you from GMAS 41. Let us move on to our next question, number 4. Let's see what we've got there. Alright, so we've got our fourth question here. An elastic material has a length of 36 centimeter when a load of 40 Newton is hung on it, and a length of 45 cm when a load of 60 Newton is hung on it. The original length of the spring is... Now for this elastic material, we don't know the original length, okay? But what we know as given from the question is when a load of 40 Newton was hung on this elastic material, the length it gave was 36 cm. Now what we're going to do is to give L1 the value of 36 cm. Okay, so the new length obtained when a load of 40 Newton was hung on it. Now, a new length was obtained when another load, okay, of 60 Newton was hung on it, and that I am going to write L2 is 45 cm, and this length was when a load of 60 Newton, I'm going to use F2 for it, was hung on this elastic material. Now we are asked to find the original length. We don't know. I'm using L0 or LO to represent the original length. Now for this question, you notice we have 2 loads, which I used F forces to represent, giving us 2 lengths. Are you following right? Now we can use the formula that F1 over E1 equals F2 over E2 to solve. Now remember from our previous class, part 1 of Elasticity and Hooke'S law, okay? If you have challenges with this formula, like you don't know how it came about, please make sure you take that video lesson. How about you pause this video, then hit this info link here. to take you straight to that particular video. Is that okay? So you get to learn more about this formula I'm using. Looking at this information given to us, there's nothing about extension. But of course, from that part 1, you will learn that extension is new length minus original length. So what we are going to do is to rewrite this as F1 all over. In place of E1, I'm going to write L1 minus L0. Then that's going to be equal to F2. In place of E2, I'm going to write L2 minus L0. So this is the formula we're going to use in solving this to calculate for the original length. Fixing up the values, we have the values here now. So you can just substitute there. That's going to give us. Now looking at this, how do you solve this? If you look at the numerators, you notice that 20 can divide them, okay? So one can say, okay, divide through by 20, so that first this 0 and 0 will go off. Now if 2 divides this 4, you get 2. If 2 divides 6, you're going to get 3. What I did was just to try to reduce this before cross multiplying. You may still decide to cross multiply and then solve, but that will give you bigger numbers. I've always talked about that. Okay, you try to work with smaller numbers as much as possible. Now let us cross multiply and see what we're going to get. 2 times 45 will give us 90 minus 2 times L0 is going to give us 2L0. That's going to be equal to 3 times 36, which give us 108 minus 3 times the original length will give us 3 original length. So collecting like terms and working out, if this 3L0 crosses, it's going to be 3L0 minus this 2L0, and of course we expect to get the original length, are you following, being equal to 108 minus 90. Now 108 minus 90 is going to produce 18 cm, 18 centimeter. Take note that I did not do any conversion of this length given in centimeter. Okay, and this is because the options provided, the unit of the original length we have to find, you can see them in cm, so no need of converting, okay? Assuming that the units provided here are in meter, then we would have to convert, the original length calculated to meter, or we can start doing the conversion from the beginning so that we solve directly in meter. In either ways, of course, converting the final answer to meter is not a problem. Divide 18 by 100, you get 0.18 meter. But of course, we don't need that conversion. The correct option here is option A. I hope you enjoyed this, right? It's making sense, isn't it? If you are here to subscribe to the GMAT 41's YouTube channel, please do so. Hit the subscription button, turn on the notification bell so that anytime I upload any new content, you will be personally notified. You will get the information. All right, let us move on to our next question, number 5. All right, so we've got the next question here, number 5. The diagram below shows the force extension curve of a piece of wire. The energy stored when the wire is stretched from E to F is, so we've got this diagram, say point E and point F. This is the curve. So when the wire is stretched from point E to point F, if you trace it, you see it will correspond to point P and point Q. Are you following, right? We are required to find the energy stored in that wire in this case. So what do? All we just have to do is try to interpret this curve. Is that okay? And how do we interpret the curve? And this is what we try to do here, okay? So that you can follow along. When the extension was 0.05, if you trace this up, to this point, once it touches the curve, to get the force that produces this extension, you can take it to the force axis. And then you would see that with extension of 0.05, the force that produces that is 0.1, as you can see. Let me bring out that value with F to be equal to, let's say F1 to be equal to 0.1 Newton. The extension produced, E1, is equal to 0.05 meter. Then, if you do the same for point F, you notice, from this point, if you take it up to the curve, it touches the curve at point Q. Once it touches the curve, you can now move it to the vertical axis, that's the first axis, to get the equivalent force, which is 0.2 Newton. So we could say that with a force, F2 of 0.2 Newton, the extension produced is equal to 0.10 meter. Now this is the data that we can get from this curve given in the question. And so with this information, we are asked to find the energy stored. E, we don't know. And we know that to calculate energy where we know force and extension, it's simply half Fe. Half Fe. Now how do we get the F? Simply subtract one of the F from the other. Is going to be, let's do F2 minus F1, giving us 0.2 minus 0.1, and that's going to give us 0.1 Newton. The same thing with the extension. We're going to solve for, this is E2, we're going to solve for E2 minus E1. That's going to give us 0.10 minus 0.05. If we subtract this, we get 0.05 meter is what you're going to get. Now that we've known the force that we need to use for the calculation, we know the extension we need to use. Now I want to recall, like I said earlier, that energy is equal to half Fe. In the case where you're given the force and the extension, so substituting, we have 1 over 2 times the force is 0.1, and then the extension is 0.05. That's going to give us, so this is the energy in the wire when the wire is stretched from point E to point F. Now this can still be written as, in standard form. There is a point here, so you move this point such that it will appear after the first non-zero digits. In that case, it will go this way, 1, 2, and then 3. So the point is between 2 and 5. We're going to get 2.5 times 10 to the power of negative 3 because we move the point 3 times. So we subtract 3 from the power of 10, 0 initially. Okay, so this is the energy stored in the spring. And of course, that is, the option here is going to be option D, which is the correct answer. Alright, it's been a wonderful one, and I hope you enjoyed the full-blown questions in part 1 of Elasticity and Hooke's law. Okay, now in the next class in physics, we are going to deal with part 2 of elasticity, where I'm going to put you through Young modulus. Okay, Young modulus. We'll look at the relationship between stress and strain. You will not want to miss that class, so I hope that you follow through, okay? Subscribe to GMATS 41's channel, turn on the notification bell so that once I upload that content, you will be personally notified. I'll be seeing you in our next class. Until then, make sure you take your studies seriously. As you take this lesson, if you have any question, feel free to make use of the comment box. Ask a question, I'll be there to respond. And don't forget, once again, you have one video lesson to take. The thumbnail will appear just a moment. Tap on that thumbnail and it will take you directly to the lesson on part 1 of elasticity. I'll be seeing you in the next class.